Okay, I just want to say that this is made for educational purposes only, so I'm not liable for any damages that may occur due to what I talk about or demonstrate in this presentation. This was made for the cybersecurity class 442 Cyber Operations at Metro State, taught by Alex Hepp. Thank you. Okay, my name is Ralph, and this is my presentation on multi-factor authentication. So what is MFA? So MFA is short for multi-factor authentication. It's basically just a process where if you want to sign into a website or some application, once you sign in, before it lets you fully sign into the website or application, it will trigger an authentication response. It'll get sent to you either through a text message or through email to further verify that you are who you say you are. This can be in the form of a text message or email, and it would ask for maybe like a code or biometrics, like a face scan or fingerprints. Basically, it just gives you like an extra form of security. So some benefits to using MFA. So like I said before, it gives you an extra form of security because if, say, a hacker gets a hold of your account and your password, just by them having your password, they'll be able to sign into your account or sign into a website using your account. So the way MFA would work is before they're able to do that, it would send you or just trigger like an MFA response to say like, okay, is this actually you signing in? And most of the time with methods that either you set up or the company slash websites set up themselves, the attacker most likely would not have access or the ability to respond to that MFA request. So that would prevent them from signing in. And then even on a business level, this would help reduce companies' I guess, attack surface as well, because it would prevent their employees from being victims of social engineering attacks, because most of the common cyber attacks start with social engineering, getting a hold of compromised accounts for those employees. And especially with what happened with COVID, where a lot of companies started allowing their employees to work remotely or just work off sites away from the office. A lot of employees are now accessing company resources either from different devices, different networks, different locations. That further increases their chances of getting hacked or becoming a victim of social engineering. And some business use cases. So most businesses use Azure MFA through Microsoft Entra ID. And what this is it's basically the cloud version of Active Directory. And through this, they can do something called conditional access. And this just basically allows them to set certain policies or criterias for when MFA should be used in their business. So with this, they can do things like determine what resources they have will require people to be able to access that resource and have to use MFA in order to do that. They can pick what MFA methods are used, whether that be like text messages or emails, face scan, voice recognition, stuff like that. And they can also decide, like, okay, if you're part of this department or this user group, then maybe you don't have to use MFA. Or if you're in this office location, then you don't have to use MFA. Or you only have to use MFA if you're in that office location. And then an example of this would be at my workplace. So in order for us and the rest of the employees to sign in to VPN, we have to use Azure MFA. So the way we would do this is by going to the VPN app on our computer, and then initiating the connection process. And once it does that, it'll bring up a web page where I have to sign in with our account using single sign-on. And then once we do that, it will then trigger an MFA action that will get sent to our phone. So it will send like an input request to our phone, through the Microsoft Authenticator app. Then we would go on our phone, and on the computer, in the login page for it, for the VPN, it will display a code. So we would see that code, then we enter that code in our phone, and it would scan our face or take a fingerprint if our phone has a fingerprint scanner. And then once it authenticates us, then we're able to sign into the website or onto the VPN. So even though MFA is a good security tool for protecting your accounts from attackers and hackers and social engineering, it can still be exploited. Hackers can still find a way around it. So these are just some ways that they can do that. So one way would be to just bypass conditional access altogether, if that's what the company had set up. And the way this would be done is, since conditional access is just like a filtering scheme, if the attacker is able to get around that filter, or they know what that filter is, they know the exact policies that are set, they would be able to take certain actions to work their way around those filters so they don't even have to go through them. Like, say if a certain location doesn't have to use MFA, like maybe the East Coast, offices on the East Coast don't have to use MFA, the attacker could use like a VPN to change their location so that the IP address that they're using is like an East Coast one. Then another type of attack would be something called a pass the cookie attack. And whenever someone's on a website or signed into a website, the website and the browser will collect certain information from them and create a profile of that user, which is called cookies. So if a user is signed into that website, it will also hold their authentication session as well. So if an attacker were to be able to steal that user's cookies, even if the user signed into that website using MFA, the attacker could then take those users' cookies, take their profile, their authentication session, put it on their computer, and then sign into the same website on that attacker's computer, sign in as the user if they know the user's password. And they would be able to do so without getting triggered for MFA. And then another type of attack would be past PRT. And then PRT stands for primary refresh token. And these tokens are used on Entra ID devices and Active Directory devices. And what it is it's basically used to hold the user's MFA session. The way it works is the device generates a key from a program called Local Security Authority Subsystem Service, or LSASS for short. And once the key is generated, the computer will then send a request to Active Directory, the domain controller, and then the domain controller will send the device a PRT or a token. And that token will be used to hold the user's MFA session, so they don't have to continuously be triggered for MFA or an MFA response whenever they wanted to access a different resource. So the attacker would, if they have access to the user's device, would go and manually trigger the key generation, bring the key to their own device, contact Active Directory, and then have the user's MFA session. Then they'll be able to sign into any resource with the user's stolen credentials without being triggered for an MFA response. And then lastly would be through social engineering, specifically MFA bombing. What this means is once the attacker has the user's credentials, they can use a tool to generate these automated login attempts to a certain website. And they'll do like maybe 100 attempts a second. And doing this will trigger MFA responses, multiple MFA responses to be sent to the users via email or phone. So the user would get so many like requests to say, accept this login. Do you accept this login? And most of the times the user would either be confused or, just tired. That's why sometimes they call it MFA fatigue instead of MFA bombing. So most of the time, people will just click accept without even knowing what's happening, just to make the notification stop. So once they do that, then they'll basically say like, okay, this attacker is allowed to sign in, and that's how the attacker will get in to the user's account. And then these are ways to prevent MFA attacks and or mitigate them. So I guess the easiest way would just be to make sure that the access policies that you would have set up, or the security engineer would have set up, are set up in a way to prevent people or attackers from just being able to find a loophole easily around them or work their way around them. Then for PRT attacks, the best way would be to not allow users to have local admin rights on their computers, even though a lot of companies are starting to do that now. And in doing so, if the attacker were to get a hold of the user's device, they wouldn't be able to generate the keys to request a PRT token from Active Directory because you need admin rights to do that. And then also disabling access to lsass.exe. That also prevents the key generation as well. Or you could do something called device binding, which basically makes it so that when the key is generated, the TPM chip in the computer will encrypt the key. So when the key is sent to Active Directory or wants to be sent to Active Directory, the TPM chip needs to decrypt it first. Otherwise, AD won't accept the request and send them a PRT token. So if the attacker was to steal the key and then put it on their device, they wouldn't even be able to use it because it's binded to the computer's TPM chip, the user's TPM chip on their computer. And then to prevent MFA bombing, you could set up an MFA method for like a one-time passcode. And the reason for that is once the MFA request is sent to the user's phone, if that's the way it's set up, then it would just ask for an input. And obviously the user wouldn't know what to input in there because the code would most likely be being displayed on the website that the attacker is trying to sign into. So the user wouldn't be able to accept the response even if they wanted to because they have no idea what the code is. And then another way you could prevent that is do something called adaptive authentication. And the way this works is it's kind of similar to conditional access, where even if the user accepts provides an authentication response to the challenge, to the MFA challenge, the adaptive authentication tool will see that, okay, are you actually supposed to be signing into here? Even if the MFA response is correct, it will check, like, are you in the right location? Are you using the right device? Is this typical behavior from the user? And it will kind of evaluate those criteria and then determine whether they'll allow them or not. So if the user doesn't typically log in at that time, even though they accepted or provided the right response to the MFA challenge, the tool would still prevent them from signing in. Now this brings me to my demonstration. Okay, so this is my demonstration for MFA. And what I did is created a tool that can be used as an MFA method for the company Exxon. So what I'm going to do is I'm going to break down this code so that you guys can understand what's happening. So these first three lines import libraries that the code will use in order to run properly. This PyOTP line imports the function that will create the one-time passcode. This line over here imports the function that will create the QR code. And this line over here turns the key that I created, which is this one, into a binary since it's a string so that the TOTP function can understand the string that I created and then encode it into base 32. Then this URI, which is the same as a URL, it creates the URI for this company, which is Exxon. then uses my username, which is Rail77. And then this line creates the QR code and then saves it into a file called mfa.png. This line creates the one-time passcode using the key that I created. And then this over here is a loop. And this just makes the code run until I manually stop it. So now let's do a demonstration. So I'm going to run the code. And at the bottom over here, it would ask me to enter the code. What I need to do first is go here. And then open up this file. And then I'm going to scan this QR code. This is the code that my code created. I'm going to scan it with my phone using the Microsoft Authenticator app. I've scanned it, and it is on my phone. So here you can see it on my phone now. So you can see how it shows my username and then the company name, and then at the bottom it'll show the one-time passcode that was created by my code. So I'm gonna do is the numbers that you just saw, I'm gonna enter them into this line here at the bottom. And you can see it says true. So what this means is that the code that I entered matches the code that my tool generated over here. So what I'm going to do is I'm going to enter in the next set of codes. That's the next set of numbers that showed up on the app now. Now that the timer's reset. So I'm going to enter in these numbers. And it says true again. So I'm going to do just to make sure that the tool actually works. I'm going to enter in a random set of numbers, which are obviously going to be incorrect. Then it says false. That's how you can see that the tool is actually checking whether I'm entering the right code or not. That is just a simple MFA method that most companies use when they have MFA set up for them and their users. So that's it. I think that everyone in the world should be using MFA, whether it's for business use or personal use, because it gives your accounts an extra layer of security. And it's honestly the easiest and cheapest, I'd say, security control that you can implement that blocks a lot of, it's typically the most sought after cybersecurity attack method that is done for attackers to go after people's accounts if their credentials have been compromised. So that's it, and thank you for listening.